We describe wires as a hot wire, neutral wire, and ground wire. The terms hot, ground, and neutral explain what the wire is doing in a circuit. Hot, ground, and neutral wires have a conductor and non-conductive insulation. The hot wire carries electricity into a component. Typically, the hot wire will be black or red. In the image to the right, the hot wire is highlighted. The hot wire is carrying electricity from the battery to the light bulb. There can be multiple hot wires in an electrical system. The hot wire carries power to each component in the system. The hot wires are highlighted in the circuit to the right. There is a hot wire from the outlet to the switches. There is another hot wire from the switches to the light bulb. The neutral wire connects the last component in a circuit back to the power source. The neutral wire creates a complete path for the current to flow. A neutral wire usually has white insulation. In the image to the right, the neutral wire has been highlighted. The neutral wire runs from the exit of the light bulb to the power outlet. Unlike a hot wire, there is only one neutral wire in a system. It goes from the last component of the circuit back to the power source. To recap, the hot wire carries electricity into a component. The neutral wire returns electricity from the last component to the power source. Recall that circuits have a ground wire. Recall that there are two types of voltage, AC and DC. The ground wire works different on an AC and DC circuit. A short circuit is an unintended, low-resistance, path for current to flow. A short circuit can cause the metal parts of a component to become charged. A short circuit can shock you or damage components. A short circuit can shock you or damage components. Short circuits can happen in AC and DC circuits. The ground wire is designed to protect the system from short circuits. For an AC circuit, the ground wire connects the circuit to the earth. It reduces the chance of you being shocked. It also protects components from being damaged. The ground wire has a very low resistance which draws a lot of current. When a short circuit happens, the current will flow through the ground wire. The excess current goes deep into the ground where no one will be harmed. The excess current will also trip a breaker or fuse that removes power to the circuit. In a DC circuit, the ground wire does not connect the circuit to the earth. The ground wire in a DC circuit acts as a 0 volts reference for the system. The ground wire in a DC circuit is called a floating ground. The ground wire acts as a return path for current to the negative terminal of the power source.